This is going to be our guiding question today, okay? What do aerospace engineers think about to make sure their spacecraft designs are suited to their destinations? So we want to think about some things that we need to know in order to create a spacecraft, right? So let's say I hold up a card. I'm going to hold up the moon, actually, because it's the Earth's moon, and I'm not sure that one of us is going to do the moon. I think we might stay away from the moon right now, because has anybody ever been on the moon?
Yeah. Yes.
Some people have been, none of us. I've not. Have you? Have you? Okay, so let's kind of take a look at one of these cards. So each one of you, each team will get a card, and you'll think about the things that you need to know. So can you read any of these elements on this card? Nice and loud, Kendra.
Location in the solar system, orbits Earth, average distance from Earth is 238,857 miles.
That's far. Okay, something else on there, Abby?
Size 2,000 miles. In diameter, one quarter the Earth's size, the size of Earth.
Okay, so these are some of the things we need to think about as we're designing a spacecraft. So let's say you're going to design a spacecraft of some celestial body out in the solar system. What do you have to consider for your spacecraft? What do you have to consider?
Maybe how big the spacecraft is.
Okay, so
if
how...
it's a tiny planet.
Any other reason why the size of the planet is important? Victoria, what do you think?
The planet's like small and the rocket's a little too big, then it wouldn't be able to fit on the planet.
Okay, so we need to know how big to make the spacecraft, right? So it can fit, right? So it can fit. Okay. What about the location in the solar system? Why do you think that that's important when you're designing or you're thinking, imagining about a design? Who cares about where it is? Savannah?
You don't want to get lost in space.
Okay, number one, we don't want to get lost. All right. Nick, what do you think?
Because if it's like really far away the planet, you might want enough like power to get there.
All right, you're going to have enough power. What do we call a power that powers us to get there? Do you know? What do we use to get there? What might you use? Julia?
I'm not really sure, either gas or energy.
Yeah, sure. Some kind of fuel, right? Right, Thomas, fuel. So enough, we need enough power to get there. And I'll just put in here fuel or something like that, right? ETC. Any other reason that we need to know the location? Angie?
Well, to know how long you're going to be gone.
Okay, how long, right? If it's really close, are we going to be gone a long time? Or if it's really, really far, you're probably going to be gone longer, right? So how long?
If it's close to the sun, it's going to be very hot, or farther away, it's going to be colder.
Okay, so how close it is to the sun, right? How close? And so I think that's going to lead us right to the temperature. Do you think that's going to lead us to the temperature? All right, so if it's closer to the sun, Abby said, it's probably going to be what? Hotter, right? So we need to know, so if it's hotter, how does that affect our design? If the planet we're going to or the celestial body we're going to is hotter, what does that matter to the design? Logan?
Maybe the spacecraft we make could be made of a material that might melt near so much heat like that.
Okay, so you want to consider the material that you're making based on the temperature of the celestial body, right? So temperature, effect on design, materials. That won't melt, right? Do you only have to consider melting?
Or freeze.
Or freezing. Why? What planet saw something? Or freeze, right? Why? What would freeze, Kendra?
Like because it's farther away from the sun, it doesn't get as much heat as all the other planets closer to the sun.
And it can be really, really cold, right? Angie?
I was just going to add something to Kendra's.
Sure.
If it's far enough away from the sun, the gears inside of it can freeze.
Okay, so the materials inside, all the gears, so things can freeze. So freeze like gears.
And the fuel can freeze.
Oh, the fuel, right? What about the surface? Somebody said surface before. Why would we have to consider the surface when you're designing a spacecraft? Vivian?
If you make the bottom of it straight, then if it's a rocky place, it won't land very good on the planet.
Very good, very good. Anybody want to add to that? Kendra.
Also, if it's rocky, it can dent the spacecraft.
Okay, so if it's rocky, what might you consider on the bottom of the spacecraft? Whatever kind of spacecraft you're making, if it's rocky. Kendra said if it's metal, it might bend. It might get bent, right? Julia?
Some kind of material that's not really hard, so it won't make a big impact on it.
Okay, so maybe a softer kind of material or something. What other kind of surfaces should we consider if we're designing something? Victoria?
If the planet's icy, the rocket, it could slide.
Okay, so we want to know if it's icy, right? So if it's icy. Good job. All right, now what about its atmosphere? Somebody said that before too, its atmosphere. We have to consider the atmosphere when we're designing a spacecraft. What do we think about that? Angie?
Some materials of a spacecraft might react differently to the atmosphere.
Okay, so the materials.
Some atmospheres are thicker than others, so it's harder to get in.
Okay, so some are thicker than others, right? Or thinner. Good. All right, the other thing I would like to talk about before I send you off to do your little activity imagining today is, what do you know about spacecrafts? Like, is there only one kind of spacecraft? Are there many different kinds of spacecraft? What might be a purpose of a spacecraft? What do you know about that? Noor?
I know some spacecrafts can carry people inside them and the people get out, and some spacecrafts are designed to do the things themselves.
Exactly. We call them manned spacecrafts or unmanned. If we go to the moon, we've had a manned spacecraft, right? People have gone up there. And have we ever had a manned spacecraft go to Jupiter? I wonder why.
Gaseous.
Okay, so it's difficult to do, right? Nobody's figured that out yet. So the goal today is for you to think like an aerospace engineer and imagine a design for a spacecraft that will visit another celestial body in our solar system. And while you're doing that, I want you to think about all these things that you have to consider, okay? In your science notebook, you have a page that looks like this. And on this page, it asks you to imagine a spacecraft that will travel on a mission to another celestial body. So first of all, what is your destination? So for example, if I get the moon, I would say my destination is the Earth's moon. Check at least 3 celestial body features that you will plan for in your design. Okay, then, why are these celestial body features important for my plan? There's a reason you're choosing them. What are the reasons that you're choosing them? And then, will your spacecraft be manned or unmanned? Are you going to have people on there that are going to get off and go investigate? Or is it unmanned? Are you just taking maybe samples or taking pictures? What is it that you're trying to find out about that place? And what is the purpose of your mission? Does that make sense? Okay. Do you think you're really going to build this? No, you're just using your imagine to think about like an aerospace engineer. And maybe someday you will build it. I don't know. You won't do it in 4th grade, but maybe someday you will build it.
Okay, now we need, why is the temperature important?
So you don't freeze. Location in the solar system is important because if it's far away from the sun, then it's definitely, it's going to be colder because it's getting less heat. And if it's closer to the sun, it's going to get more heat.
We did 4.
You're doing 4? That's good.
Because we couldn't decide between atmosphere and location, so we just did both.
Can crush.
Are you going to have it manned or unmanned?
Unmanned.
Yeah, it has to.
Because guess
It
what?
can crush a person.
It can, the atmosphere,
It's 90
atmospheric
times
pressure could crush a person.
And it's 90 times
So
the
of course it's not going to be us.
So the pressure
Yeah,
is
because you
90 times that?
You can't go into it's not atmosphere because it would just go like.
So you don't want to put somebody out there? No.
Can we just say like a
need to make it
material
feel
that is heat-proof or something?
Okay.
That won't
A
melt.
material that
A metal that will not melt.
5 more minutes to draw, and then we want to share these out. These are awesome. So yours is definitely manned,
Yeah.
and you have something going out to get what, samples?
Yeah,
Yes.
and pictures.
And pictures. Good. So when you come up, bring your yellow card so we can talk about the celestial body you had, and then let's talk about some of your designs, okay? You're going to stand right up here, and people can see your design. You'll hold it up and just kind of explain what you did. Jupiter, come on down. So when you come up and talk about it, I would love for you to say the features that you considered in your design. Features you considered in your design.
We decided to do location in the solar system, temperature, and surface. The surface is important to know because we don't want to land in any gases.
The design for our spacecraft was gonna have the fuel up on the top and then cords going down so that the fire could come out.
Right. So, our destination is Venus, and we did the temperature, the surface, the atmosphere, and the location of the solar system.
What did you have?
Our destination was Mars.
Mars. Interesting.
And we considered the location in the solar system, the temperature, and the surface.
The temperature is -200 degrees to 68 degrees Fahrenheit. So just in case if it is that -220 degrees, we put 3 layers.
Very creative, engineers. Nice job. Round of applause for all of you. I have 2 pictures. This is from NASA. And these are 2 pictures of spacecrafts that are actually out there. One is a satellite. Does this look like anything that you've designed on yours? Yeah, a little bit, right? You did a great job. And do we think we can answer this question now based on all the work we've done today? The guiding question this morning was, what do aerospace engineers think about to make sure their spacecraft designs are suited to their destinations? What are some things they think about? Devin.
How big the spacecraft can be.
How big the spacecraft should be. Doa.
The location of the planet.
Very good. Location. Alexis.
How much fuel they'll need?
Absolutely. Thomas.
The temperature of the planet they're going to.
Absolutely. Noor.
The material they need to make.
Materials are huge. Materials you need. Kiana.
The atmosphere.
The atmosphere.
The surface.
The surface.
How much things you're gonna put on?
Exactly. All the things you need to put on there, Julia.
There's a lot of other stuff.
And a lot of other stuff as well. Round of applause. Tomorrow we start testing materials and thinking about our designs. Lesson 2 is the one where they designed that spacecraft. And I think they took away good things about that. One was understanding all the things you need to know, like other properties of celestial bodies that are in space, so that not everyone is the same. You have to consider atmosphere, you have to consider temperature, the distance from the sun, all of those things. Fuel tank, how much fuel you need, how close, all that stuff. So lesson 2 gives them a really good understanding of that. Their spacecraft designs were really, really, really thoughtful. They shared good information, good conversation. When they imagine something, we usually have them imagine it by themselves. In the end, some teams decided to kind of take pieces of it. Other teams did their individual ones and compared them. But the goal was to have conversation and understand it, and they all did that.